Okay, so you see my notes. I'm trying to be, precise with my time. It's always a challenge to, keep up with, the time, and yeah, I'm unmanageable. So just to show my presentation. My presentation is already available on GitHub. So if you are wondering, what slides I showed, or I'm showing, or I'll be showing in a moment, and what's there or what's not there, you can find it here, okay? So I just worked on them. I finished working on them just 5 minutes ago. So all the bugs, are not mine. I'm gonna blame someone else. And it's always like this, right? We ship to production just right after we finish our coding, right? So I just finished my coding, and moreover, I just upgraded my Reveal.js I'm using for presentation just a sec ago, because I saw that 10 days ago, they just upgraded to Reveal.js. Reveal.js is available, so freshly baked Reveal.js is used for the presentation. Okay, so my name is Jacek Laskowski, and I'm here to show you how to use Spark SQL and Spark, well, I call it Spark Streams now, Spark Structured Streaming or Spark SQL Streaming, especially for aggregations, okay? So there are lots of crazy operators I hadn't heard before I started working with Apache Spark. So I'm here just to show you what I learned and what Spark SQL can teach you. It's not necessarily about Spark SQL or Spark Structured Streaming. You may use this knowledge for SQL in general. Okay, so from basic to more advanced aggregations. I'm Jacek Laskowski. I'm independent consultant working exclusively with Apache Spark, with some some other tools like Kafka, because Kafka is just a shock absorber, how I call it. Just kind of like a database. Jay Krebs just published an article saying that, or claiming that Kafka can be used as a database. So yes, Spark uses Kafka as a kind of a database to keep all the data. So I'm with Spark, Kafka, obviously Scala, because I need programming language, because we all know that Apache Spark is nothing else but just a library we can use for distributed computations. Okay, that's all about Apache Spark and Kafka and Scala, and Mesos, because we need a deployment platform. So it could be Mesos, Yarn, or Spark Standalone, or now Kubernetes, which is coming, support for Kubernetes is coming in Apache Spark. So probably not in 2.3, the upcoming version, but might be available in 3.0. Yeah, might be available. It's just coming. You can contact me at jacek.yapila.pl to just ask questions about Spark and all the technologies that Spark may or may not be using. I'm publishing all my thoughts about Apache Spark on my GitHub, and which pushes all the changes to Gitbook. And as you can see, some people found my notes quite interesting. So yeah, I reached this 15K altitude now. So my cruising level is now 50K. I just started taking notes about what I'm gonna share with you. So this is another book, another Git book, never-ending story. It's not gonna be ever finished probably, but it's about Spark Structured Streaming, which is the streaming solution on Apache Spark. And just yesterday, I was told that people don't know that they can read these Git books on their mobile devices. And yes, there is PDF, Mobi, and EPUB version available, so you can download it and read it while you are on your go. And I'm also active on Stack Overflow, so you can find some of my contributions. Quite recently, I saw that people downvoted some of my answers. Looks like I need to be more careful what I answer and how I answer. I thought that I know what I'm talking about, but looks like some people claimed I did not, especially on Stack Overflow. This is my talk. So again, this is about basic and not so basic, probably advanced aggregations that are available on Apache Spark. When you look at Apache Spark, you will see that there are few layers or few perspectives. You can look at this beast, so to speak, this product, this project. And for some people, it's about SQL. For some people, it's about streaming, probably streaming with SQL, and machine learning and graphics. If you are wondering what's the value proposition of Spark, especially Spark Structured Streaming, compared to tools like Akka Streams or Kafka Streams, I'm here to tell that the only difference I can see is MLlib. This is the value proposition I can see that Spark is pushing to the market, and this is the main differentiator. So I'm going to show how to prepare your data so you can do, let's say, machine learning. Okay? This is our agenda. Well, it's not a complete agenda. I'm going to use, this Reveal.js feature fragments to show you only what I'm going to talk about. And we've got 45 minutes. Hopefully, that's enough. Okay? So if you are wondering, I'm using the slides I'm using for my workshops because, I don't want to waste your time, showing you something that I'm going to bury after my talk. So you can find these slides on my GitHub, and they'll be using on my workshops if you ever wanted or thought about attending one. So basic aggregation. What's basic aggregation on Apache Spark? Well, it's all about groupBy and groupByKey. The difference between groupBy and groupByKey is that groupBy is untyped, while groupByKey is typed. What's the difference? Well, we all love Scala, don't we? So we all love Scala, and the reason we love Scala, or we still with Scala, despite all the hate towards this language, is that it's functional and it's fully typed, right? So you can say something about types you are using. So Scala, since it supports, Python, R, and Java, is not necessarily so focused or so obsessed with types, yet it just knows that types are important. So there are two APIs, more for Scala and not so much for Scala developers, possibly for people who love more dynamic environments of Java, Python, or R, or the all-beloved language called SQL. So aggregate functions, what are they? There are over 100 aggregation functions available in Apache Spark. They all work on groups of records, okay? So now the question is, how to create a group of records? Well, you've got your large data set, well, larger, okay? Wish I could, show larger data set using my hands. So this is just that number of data, and this data needs to be processed in parallel, not because we love distributed computation, but because we need to compute our answers quickly. So there are 5 V's: velocity, variety, volume, something else. Okay, so there are 5 V's that say this is big data. And big data is not only about how large your data set is, but also about how quickly you can come up with answers. So we've got these aggregations. And to be honest, just quite recently I discovered that all our processing is about grouping and joins. That was kind of surprising to me. Probably it's not surprising to you, but to me it was like, oh man, I spent so much time with Spark and just discovered that groupBy and join is everything I want for processing my data. Correct? Would you agree with this? Do I miss something? Do I miss this ingredient, this special ingredient for processing data? I don't think so. So aggregate functions work on group of data, and we've got AVG, collect list, count, mean. Yeah, I apologize for my pronunciation, and sum. So you can also create your own aggregation functions using this user-defined aggregate function interface. Yes, so if you are not satisfied with what's available, you can create your own. OK, we've got this AGG operator that you can use after creating your group. And you know what? I just discovered that you can consider your data set, your large data set, as one large group. So you can create, you can count the number of records because there is one group that holds all the records. So you can apply, AGG function right away on your data frame or data set. And that was kind of surprising, and I found some people who found it surprising too. So you've got this AGG operator that can be applied directly on data set, considering data set one large group. And this is an example where you range over 10 records, and you can apply this sum over IDs that you will want to call later on as sum. Okay, that's pretty easy. Okay, so yeah, there's this exercise. You can just go through it. If you need help, just ping me. You've got this groupBy that can say, okay, this is my discriminator function that will partition, not necessarily in this Spark partition way, but let's call it partition or split your data into chunks. So you can apply your aggregate functions. Easy, right? Easy. So you've got this groupBy. You can use it with AGG, but knowing that AGG can be applied directly to dataset is also available. So you've got this exercise, another exercise, another exercise. Finally, you go to another basic operator, another basic grouping operator called groupByKey. The only difference is that you've got types. You are all here for learning more or mastering more Scala, or mastering Scala in a more sophisticated way. So you've got this groupByKey, and groupByKey accepts just pure Scala function. Okay, it's not available with groupBy because groupBy uses some other types that are like they are very generic. Okay, so you've got this groupByKey operator. But my take on it is that despite being so cool for Scala developers, I am not recommending using this interface, groupByKey. I hope I find someone who tells me that I'm wrong, but my take on it is that it creates this additional layer of serialization and deserialization between internal representation of data that Spark keeps under the covers. So there is this Tungsten project that introduced internal row that's pretty much like Parquet or ORC format. So Spark, whenever it touches your data, makes it highly available, so to speak. Okay, and very performant. Okay, so whenever you go through this interface, you will deserialize from this internal representation to your Scala object that may or may not be something you wanna have eventually. So know that this interface is available, and this is the point behind this interface is that it provides you with these nice functions called reduce groups, map values, map groups, and Flatmap Groups. So, and these are operators we are gonna use for streaming. Okay, am I fast enough? Good. So, explaining. So, I like this pun that whenever I say, okay, let me explain logical and physical plans. Yes, whenever you think about Spark as a kind of a database, distributed database, you're right. That's my take on on Spark too. The only missing piece I could say why Spark SQL is not by definition, you can come up with a database, regardless whether you could think about SQL or no SQL database, is that it does not have storage. Okay? And storage is usually Kafka, or HDFS, or S3. Okay? So combining these storages plus execution engine, you can think about this environment, Spark plus storage, as a kind of a database. I'm pretty sure that database purists would say that I'm telling you something crazy. But anyway, there is this notion of explaining logical query and physical plans. So whenever you write your code, you can see how Spark looks at your code, or what Spark sees. Okay? So Spark optimizes your code and executes something sometimes completely different, yeah, it's semantically correct and exactly what you wanted, but it rewrites parts, especially now with CBO, to the point that Spark says, this is the quickest and fastest query you can ever write. And this is good because by using this explain operator, you can see some nice things like, let me show you. And by the way, just yesterday I learned about this Spark submit opts -d Scala color true to enable coloring in Spark Shell, which is pretty cool. And it's available in Scala 2.12, but 2.12 is not supported by Spark, not today. Probably might be available in 2.3, but there is one bug that's still unresolved. So this Scala, okay, so I've got this Scala, and look at this. I create this nice-looking 5 or 6 record data set, which is pretty nice and pretty easy. Yeah, I'm trying to show you the easiest parts of Spark just to convince you to dig deeper. But anyway, so you've got this show, and now I'm gonna say, hey, show me the execution plan you used for executing this simple-looking query. And this is explained. If I need more, because this is physical plan, I say extended true. You don't have to use this extended parameter. And now you see parsed logical plan, analyzed logical plan, optimized logical plan, and the last but not least, physical plan. This is what Spark sees after you write code. Good. So this is explained. So that's all about basic aggregation. Oh, I'm short on time. I feel it. So window aggregation. Window aggregation is pretty cool, and I found many people who haven't even heard about window aggregations. And they are cool because usually you're grouping to join your totals with some, let's say, initial data set. You don't have to do it. You can use window aggregation and have it have this, group by plus join with one single code, okay, or line of code. So let me show you window aggregations. Yeah, there are lots of things to cover, but just know that window aggregation has this notion of current record. Current record is that it's like a cursor going through your data. So it's not something you can find in groupBy. So in window aggregation, you can say, hey, give me all the records that belong to the same group that this current record belongs to. Okay? So by going through this record, Spark automatically calculates all the groups. Why? Because you need to calculate some totals, some aggregations, some aggregates. So you've got this special window aggregate functions, and the difference between them compared to regular aggregation functions is that window function generates a value for every row in your data set. So compare it to groupBy aggregations, where you get at most the number of records after your aggregation you started with. With window aggregation, you will get exactly the same number of aggregations as the number of input records in your initial data set, or you applied this window aggregation to. And you've got these window functions like ranking, like entile, row number, analytical functions, cube, and the good old aggregation functions. They are also available for window aggregation. Okay, you start with this window specification that resembles groupBy-like constructs, where you say how your discriminator function looks like. And so you use it for window specification. You can apply partition. You can apply ordering. You can also apply this range specification, where you say, hey, if there are any gaps between records, make these groups separate, even though groupBy would end up with one group. Okay? So you create this window specification just like this, import expression window, and then you use this over column operator to apply this window specification to your data, okay? And then you use this execution environment, be it filter and select with column, depending whether you are adding new columns or you limiting the number of columns in your output. So all in all, you apply this window specification by using this over operator plus the function you are interested in. So maximum, average, rank, entile, they are all to be applied over your window specification. And you know what? It's also available in SQL. And you know what? I didn't know about it before I started working with Spark. So by using Spark SQL, by using Apache Spark, I just became a better SQL developer. Do I need it? I'm not sure about it, but still, okay? So there are some exercises, and these exercises are from Stack Overflow. So you can find links from some of the slides to Stack Overflow, and think about your solution using groupBy. If I ask you, hey, give me first and second bestseller, let's assume that you can say something about second bestseller. So first and second bestseller out of the records you collected over time, okay? With groupBy and join, that might be tricky. With window, it's no-brainer. Okay, you want to see the solution? Well, attend my workshop. So there is this gap between the records. You can calculate running total or cumulative sum. They are all the analytical problems people face while working with Apache Spark or with big data in general. Okay, so that's window aggregation. I'm pretty sure that I'm running out of time. So multidimensional aggregation, that's pretty cool. You know what? Look at this. Multidimensional aggregation is the least explored area by Scala and Spark community, I noticed, and me including. So I'm here only to say that these ingredients are available, but don't ask too many questions. If you are curious about lower level bits and bytes, I might be able to answer this or that question, but overall, speaking about use cases might be a little bit tricky. Anyway, you've got this rollup operator. Who has ever used rollup in SQL? Oh, you see? Who has ever heard about a rollup operator in SQL? Oh, one person. Okay, good, thank you. So as you can see, this rollup is very powerful and less known or not widely known. It's to create multiple groupings over cubes that you can specify by this, cubes by specifying this rollup. So there is this rollup operator that you can use with groupBy, kind of like groupBy, and you've got also, this is one use case, you can also use this more general cube that not only gives you all the possible not all the possible. All the variants by looking at the position, just like rollup, but by having all the combinations of all the dimensions. They call it dimensions, okay? So you've got rollup, cube, and the last but not least, very powerful grouping sets. The trick behind, or the interesting point behind grouping set is that it's not available as a data frame or DataSet API operator. It's only available using SQL. So now you learn that there are some functions, there are some operators that are available using SQL, and there are some operators that are not available in SQL, which are available in a Spark API for Scala, for example. Okay? So you've got this grouping sets. And you've got this grouping aggregate functions. Yeah, it's available too, and grouping ID. But let's skip it because our 20 minutes, are gone, right? Am I correct? Did I only consume 20 minutes? Who is to confirm it or, say that I'm wrong? So 20, about? Less or more? 21. Awesome. Yeah, let's keep the pace, okay? Okay, good. So now let's switch gears and let's go from batch processing to streaming processing, okay? So we were in Spark SQL. Now we go to Spark Structured Streaming. What's cool about Spark Structured Streaming is that you don't have to deal with this bits and bytes of Akka streams or Kafka streams. You can just use your beloved Spark for something that you can find, elsewhere. Okay? It's now available in Apache Spark. So let's go from batch to streaming. So I'm gonna show you what it takes to use Spark Structured Streaming. Okay? So let's go very deep, under the covers. So, I can see that the style sheet is broken. Anyway, so stream execution. Stream execution is nothing else as a separate thread that handles your one streaming query. So the difference between what you may have found in pre-Spark 2.2 in Spark Streaming is that now you can have as many streaming queries as you want, as your operating system, your JVM can handle. Which means all streaming queries boil down to threads. So when you do JConsole or JP or JStack, you will see all the different threads that are running for executing streaming queries. And this guy, streaming execution, is responsible for one single streaming query. So now the question comes, how many streaming executions objects can I have? As many as I want streaming queries. And the beauty of this, and the trick, that took me some time, is that streaming execution is a thread. Yes, I said it. Hopefully my pronunciation says that it's something positive, not negative. Thread, you see? Thread. You see? So it's not a thread, it's a thread. Hold on, am I correct with my pronunciation? There is a difference between those objects? Okay, good. So streaming execution. So streaming execution is nothing else as a thread that manages all the sources that you can use for your query. And by combining all of them, and I'm lying a little bit, you output your data. And the lie is that in Spark 2.2, you are not able to use more than one streaming query because joins are not available. You can only join in Spark 2.2 between streaming dataset and batch dataset, okay, or multiple batch datasets. So this source is not necessarily source in a streaming definition, but just a data source, okay? In upcoming Spark 2.3, you can inner join multiple streaming sources. So support for multiple sources is coming. Now the question is, okay, we've got multiple streaming sources. It's coming in now being voted Spark 2.3 release. It's just coming. It just days away from today. And so now the question is, how if we have multiple streaming sources, how many streaming sinks, the outputs, can we have in one streaming query? Just one. And it's by design. You can create multiple queries that will output to different venues, to different outputs, to different sinks, but it's just to create another query. Okay, so now you end up with two queries. Okay, so, and the nice thing about the streaming execution is that it's a thread, so it runs in parallel to your application, but also that it gives you all the time-boxed measures or executions like get offset from your sources, wall commit to preserve what was already processed for one process once semantic, and get batch, query planning, add batch, and it's all wrapped into this trigger execution. So you've got these measures, so you can look at separate steps of your query execution and say, exactly where the lags, where the delays happen. So under the covers, there is under the covers of stream execution in Spark Structured Streaming, there is this stream execution that handles the thread that's responsible for your query. Okay, good. And you can also ask about this last progress and recent progress after you start your streaming query. There is also this incremental execution, but it's too much for today. So now, 25 minutes passed. Just 25?
27.
Damn it. OK, so let's keep the pace, because I am slowing down a little bit. And I've got plenty to cover now. So now we are in this Spark Structured Streaming. So the difference between Spark SQL and Spark Structured Streaming is that now all your SQL queries are executed continually or continuously, OK? So they are running as if you executed cron job or marathon, whatever, and you said, every 5 seconds, I want to execute this batch query. That's Spark Structured Streaming. OK? There are works to make this less batch-oriented, more real-time, but it's I'm not going to say it's coming. It's just that there are some works, OK? So in a sense, it's coming, but no one knows when it's going to be available. So for now, just look at Spark Structured Streaming as an engine, like a cron, to execute your good old SQL queries continuously. That's it, OK? So, streaming dataset API for aggregates. Now I'm going to use my book for Spark Structured Streaming. OK, so we've got this dataset API, very nice dataset API. There is this distinction between batch and streaming datasets. And among the dataset API operators, there are some that are particularly interesting or suited for streaming computations. OK? Among them are drop duplicates, explain, which is kind of special, but it's not so much. When you look at the code, you will see the difference between streaming and batch processing. But from the outside, they are same. So groupBy, we all know and used for regular, good old SQLs. groupByKey, we all know, and this with Watermark. They've got special support for streaming datasets, OK? And this special support is because we need them because, we are aggregating over data that changes over time. Now the question is, when to output your aggregate, when to output your calculation, your total. So if you are summing over collection of records, you say, OK, 5 minutes passed. Am I finished with all the data that I need to calculate this total? I don't know. And no one knows, unless you've got some guarantees from the source that, yes, these are all records to process. What if your client is in the elevator blocked internet access, and all the data from the smartphone or all the data is waiting for network connection, and this network connection happens after you decided that your block is finished. It appeared it's not. So your calculation should restart, taking everything that was already aggregated or prepared for aggregation, plus something that was late. So now there is this notion of watermarking or lateness, where you define how late your data can be. So think of it. You can say, I'm going to wait for my data forever. Well, you can, but think about all the data that's being collected over time, over this infinite time period. You will get no results because your window hasn't finished yet. And your data will grow, your disk space will drop, every batch, because new data will arrive, this data will get stored, and then what? So there's this notion of watermark. And this groupBy and groupByKey are specially designed to handle these cases, okay? Okay, very good. So we've got this DataSet API, streaming DataSet API, and we've got groupBy operator. So let's look at this groupBy operator. That's pretty simple, you know. You know it. You've been using it. Yeah, this fix me is just for me. You just pretend that it's not there. So you've got this groupBy by using columns. You can specify 0 or more columns, or you can specify columns by references that are of type string, which forces you to use at least one string-based column reference. So how does this, you know, how could a simple groupBy-based aggregation look like in Spark Structured Streaming? Let me make it a little bit bigger. So I'm reading from Kafka. No need to, you know, to go into this integration details. You just define this format Kafka, and it just plugs Kafka support to your streaming queries. Then you say, hey, subscribe to topic 1, and these are my bootstrap servers. This is, you know, Kafka specific, right? And you load. After this load, you just created something that's continuously updated. It's dataset that never finishes. So, but you need some data, you need some aggregations. So you say, hey, from this topic, give me values, they are bytes, so you need to cast them to string to build, you know, it's kind of like string deserializer. Then you say, hey, create this column, tokens, by splitting this value, and this is just regular, you know, SQL transformation, until you get this time, key, and value. Now, you've got time, key, and value, and you know that I need time to say whether this data is proper and it's not late. So I can window it or window over this data, let's say over 5 minutes, by looking at event time, not as it was in pre-2.2 version of Spark, by processing time. Now we've got processing time and event time-based computations in Spark Structured Streaming. That's why I'm telling people, forget about Spark Streaming because it's dead. If it's not, it should be. So counts, you just create this timed values with Watermark because you say, hey, if there is late data, after 10 minutes, I pretend this data didn't arrive. Okay? So this is how you specify this watermarking. So you've got this data. It's not very type safe. Yes, I can see it. But this is just special string-based DSL in Spark SQL where you can say every 10 minutes. So, and groupByKey. So by using this watermark, grouping by key, you group over keys to collect list of values and list of times that I collected, knowing that 10 minutes is the time of the last record that is considered part of this group. So I will get at least one result after 10 minutes, because after 10 minutes, the time expires, so I can get my first total. And this is just you know, looking at this. So this is pretty easy, right? So yeah, this is this demo, so I'll skip it. I'm worried about this. About time, yeah, always worried about time. So groupByKey operator is just more sophisticated interface to functions I'm gonna explain now. So, not now, but now. So, by skipping, you know, this demo, groupByKey and window function, and with Watermark, I'm just inviting you to, you know, explore Apache Spark with me or on your own later on. But because I think that explaining groups with state is very powerful to convince you guys that Spark Streaming is dead. Because Spark Structured Streaming gives you all the optimizations that are available in Spark SQL. You know, internal representation of your data with input. You mean high five? 5 minutes. OK, 5 more minutes. OK, so map group with state operator allows you to manage your state, your internal state. So it's very stateful, yet because of, you know, semantics of map, you need to generate one value for one group, right? So this map group with state is a Scala map operator over stream, unbounded stream of data in Spark Structured Streaming. So, but the beauty of this, typed API provided by groupByKey is that you've got this Flatmap Groups with state operator. Wow, what a name. It took me a while to figure out how they came up with this name, weird-looking name. But there is a merit behind this name, because it's Flatmap, and we all love and use often a method Flatmap in Scala, right? Then groups, because it's Flatmap over groups with explicit state. So now you are in charge to say what exactly you are grouping and how. You code it exactly as if you coded this solution from scratch, but you've got help from Apache Spark, and all the optimizations are available. So you are bound, or you are limited to types that are supported by Spark. So Yoda time or brand new time API in Java 8 are not supported, unfortunately. You need to go to Java SQL, timestamp and date. Because for them, you've got encoders, but for other types, writing encoders is an art in Spark SQL. So it's this function that will deserialize your internal representation of your data into Scala object. So writing it requires a lot of expertise in low-level bits and bytes of Spark SQL. I am not inviting you to explore this area, not today. So Flatmap Groups with state is very powerful. At the same time, it's very complicated, at least at first sight. Look at the signature. See? How many times you see signature like this, even in so crazy Scala libraries you might be using, probably Cats or Scala Z could beat it, but this is pretty crazy, right? Thankfully, they did not use any mystic, operators you cannot find by Googling. So Flatmap Groups with state accepts output mode. There are 3 output modes in Spark 2.2. There is complete, append, and update. There is timeout config, where you say, hey, I'm gonna control when I'm timeouting my groups, when I output my data, and then there is this function that will accept k. What's k? No. I'm not asking about this men in blacks. I mean this k. So what's k? K is key, because you are grouping by using keys, right? So you've got key, iterator of v. What's iterator of v? V are values. This is the type of your values. You've got iterator because at one point in time you can have multiple values, 0 or 1. And by the way, iterator is lazy. And group state is just the state you are working with for this k, for this key, okay? And then you just create this function to say, okay, out of this k, iterator of v, group state of s, you create iterator of u. And you know what? What's u? U is the type of something you will output to this data set of u that you will be working after this Flatmap Groups with state. So yeah, it's complicated, but hey, you've got a very powerful tool, so expect surprises, yet you are in charge of doing every bit and byte of this stateful processing using Spark SQL. That's why it's called arbitrary stateful operator, okay? Or operator for arbitrary stateful streaming processing, or stream processing. Okay, so there is this example here, but I'm not gonna use this to introduce Flatmap with state, because I hope that the time ran out. So is this correct? It's correct. So we have time for questions. This is my first talk where I cover so much, and I've got time for my Q&A. That's awesome. Thank you so much. Yeah, or 10. They are so, curious about, all the bits and bytes.
Yeah,
so let's give them, so 10 no, 3.
We have to give time for another man from Sportsradar who...
Oh, okay. Oh, yeah, okay, deal. Okay, so what are your questions about this? You got curious about, how all these operators work in Spark SQL? Yeah, some people say, yeah. I pretend no one say, yeah. Okay, so are there any questions?
We have time for 3, not none.
They say that I'm pretty good at explaining, tough problems, so they've got no questions because I explain everything, right? Oh, Holden is coming up with, Okay. Now she's shooting.
Friendly question.
Okay.
So for people who are thinking about implementing their own aggregators, do you have any examples that you would send them to look at to see good aggregators implemented in Spark?
Okay. So the question, if I understood this correctly, was about aggregators. And now the question is, what exactly, what aggregators she was thinking about? Because there might be simple aggregators or this, window-based aggregators, more complex. So for simple aggregations, yeah, there are some examples on Stack Overflow. The interface is pretty basic and pretty easy to implement. If you follow the types, you will finish it with ease. There are some quirks, some initialization. For Windows aggregation, I haven't spent much time on this, creating custom window-based aggregation, but the interface is 4 methods, if I'm not mistaken. So again, by following the types, you should reach this comfort zone where you say, let me run it. Okay, there is something that works, but why is it working like this? And then this question will lead you to proper answers. Then you need to spend some time with code because there are no documentation about this. So all in all, the deeper you go into Spark SQL, the less documentation you will find. So yeah, because it's all pretty new. Okay, so finding proper answers might be a little bit tricky, but it's coming. Did I answer your question, Holden? Kind of. Thank you. Yeah, that was a kind of a friendly question. Yes.
As return value of aggregator, should it be just a scalar value, or could it be, for example, array with distribution of values?
So,
I want to return the distribution of values as aggregated function of some array.
yeah, so you've got this array already on your JVM. If you've got this on JVM, why are you using Spark for this? It's handled by one JVM, so why are you employing Spark?
I have a lot of data, and I want distribution of this data across some value ranges.
Okay, so your question is how to do it?
Is it possible to do it with aggregation function?
Without or with aggregation? With? Yes, it's possible. I'm not sure what he's talking about, but yes, it's possible. What else could I have answered? sorry. Yeah, I'm kidding. Yeah, it's possible. Spark SQL and Spark Structured Streaming is just library. It's just API that you can extend. As a matter of fact, I haven't met anyone who created its own Spark, but I'm tempted more and more to create my own distribution with my own functions, because that's exactly what this API forces you to do after you want to do something more complicated. The API is rarely open when the developers, committers, Spark committers, are not sure. They are sure about, this API should be like it is today, okay? So they close it. So to do something more sophisticated, let's say with encoders, you need to go and rebuild your Spark distribution because there are lots of private methods. They lock it because you are not supposed to use them. But if you wanna be on bleeding edge, there are no choice. So the answer to your question would be, I'm pretty sure that pretty much everything is possible with Spark if it's about distributed computation. It might not be the best way to use Spark, or it might not be the best solution for your problem, but I'm pretty convinced to say Spark can handle pretty much all the distributed problems we are facing today. Okay?
Thank you, Jacek.
Thank you.
We're gonna